Prototyping is the conversation that you have with your ideas. The reason why we must have these conversations with our ideas is that as long as those ideas are stuck in our heads, everything seems to be possible. And we need to learn when our imagination is failing us. The faster we learn what is wrong when we are wrong, the faster we can get it right. Welcome to Rapid Prototyping, part 4 of our From Idea to Innovation series. I'm your host David, and if at any time of this video you think, hey, this is cool stuff, then please hit the like button, share and subscribe with the links below. And if you don't like it, please let me know in the comments or ask any questions or give me any suggestions how to improve the videos. With no further ado, let's get started. And hopefully this time it looks better. That's what we wanted to see. So about 4 weeks ago we kicked this off with an overview over the design thinking process. And the beauty of the design thinking process is that it is guiding us through the innovation cycle and keeps us on track with processing. 3 weeks ago we learned how to find out what our customers, our clients, our users really want with empathizing with them, and we defined the personas that we want to design our product or service for. And then last week we talked about the ideation process in general. I introduced you a couple of ideation methods that you can apply in a team setting with your partners, with your family, with friends, but also with your team at work. And we emphasized, according to the current situation, methods that can actually be used in a remote setting as well. So if you haven't seen that, please feel free to jump back after this is over and have a look at my previous video. Today we're talking all about prototyping. We have a lot of ideas, now we have to make them real. What is a prototype? A prototype is an early model or a sample or release of a product built to test a concept or a process. And there are different categories, different disciplines that we would like to test with our prototypes, or as we said, since prototyping is having conversations with your ideas, there are different conversations that we would like to have with our prototypes or with our ideas. First, we want to know if it's feasible. Can we actually build this idea? Can we make it real? It's very important, obviously, because there is no point in investing much more resources into something that we won't be able to actually build and deliver. We definitely need to learn, do our customers, our users want what we design, want our product or our service? Is it desirable for them? Or probably we were wrong with our first assumption and our target market does not really like the product or service, but there is another group of people that are actually quite keen to give us some money for what we're going to deliver. And we want to have a conversation about, is it a viable business that we can create? Assuming that everyone wants to use it for a business purpose, obviously you have to have a positive cash flow at some point of the business, and that's something we can learn with a different conversation, with a different test of our prototypes as well. And then there are different levels of complexity of prototypes. Most of us have probably seen at least bits of the introduction of Elon Musk's Tesla Cybertruck, and this is a physical prototype, a drivable prototype, which we would call a high fidelity prototype. It does have a lot of complexity, a lot of detail in it. And what Elon Musk wanted to test with it in the first place by the presentation is how desirable is his design, And as a side effect, he was also able to test how strong the windows really are, which did not quite work out the way he wanted it, or probably it did. We don't know for sure. Building such a high fidelity prototype, a physical car that took the whole engineering and prototyping department from Tesla at least 6 months, probably more, closer to 12 months time. That's a long time to wait for. Now the other spectrum, there are low fidelity prototypes, and those can be brought to reality much quicker. So obviously, a low fidelity prototype like this sketch or drawing of the Cybertruck does not offer us the depth of detail and the depth of testing, the quality of testing that we want, but it helps us to actually discover in a lot of cases already what's not working or what is working. In this case, since the design is so polarizing, the design of the Cybertruck, if Elon Musk would have posted that and would not have followed up with a real physical car, we probably would never have believed that the thing is really going to look like this. So the quality of just doing his presentation introduction of the Cybertruck just by using a low fidelity prototype would probably not have yielded the results that he was after. But creating such a low fidelity prototype can take you as little as 30 minutes, 60 minutes if you're a skilled sketcher, and you often will learn quite easily if proportions, for example, are working out nicely and stuff like that. So low fidelity prototype are quick. High fidelity are taking a long time, but giving us better quality. And the value of a prototype is in the education it gives us. We want to learn from our prototypes. High fidelity, deep learning; low fidelity, fast learning. With low fidelity prototypes that can be built and brought to life within just some seconds, or not some seconds, but in between half an hour and probably a day, you can do a lot of testing. If after half an hour of designing, building your prototype, you figure out that's not going to work, next one. You can probably test 10 prototypes in the very early stages, 10 prototypes within just one day, when you keep it low fidelity. And it does not cost a lot either. So before you basically learn a lot of things about what is working and what isn't working in a short amount of time, little investment in money, and then you can move on with the prototypes that did turn out to look visible from the early stages. The easiest way to get started with prototyping, with getting your ideas out of your head, is starting with sketching. And sketching in a more comprehensive way, like sketch the environment of your prototype. Right, so if you for example design a mobile app, sketch it with the phone in there, so you see how it looks on the screen. For example, sketch different screens that your mobile app will have, and see how it works, how it looks like. That is quick and easy, and either by yourself or with a team in front of a whiteboard, you can pump out a lot of very low fidelity early prototypes in just a couple of hours. Physical product like this is Google Glass, which is, for those who don't know, a head-up display. So there is a thick glass prisma in front of this woman's eye, where you can see search results within your view. So you still can see the real world, but you also see whatever Google is going to show you through the internet. So it's kind of one of the first augmented reality products that was released into the market 10 years ago. Was not a big market success back then because people did not like to wear something like this in their public lives, going out on the street, having this block of glass in front of their eyes. But I recently watched a video of Tom G. He was one of the designers involved in coming up with a Google Glass, and those are some of the real sketches that the Google design team used back then. And basically, as I said, it's augmented reality. It projects an internet site or Google Maps into your eyesight. So it's a head-up display, and the first prototype of a wearable head-up display that they came up with in their design studio back then is the sketch in the upper right corner, which is basically a screen that they've placed 1 meter in front of the person, and it was carried by a beam and a coat hanger that was hanging around the person's neck. They placed a small projector on top of it, and via a netbook they loaded the websites onto that screen, into the projector, and projected it onto the screen. And with all the resources that they had, obviously they had a fancy design workshop studio. It took them 45 minutes to get this prototype, for the first prototype for Google Glasses, going. And then the next day they were thinking, back then, where we're talking about 2008, back then voice control wasn't as advanced as it is today. They figured out they asked themselves the question how to control the websites that people are seeing in front of their eye. And they thought about doing it with gestures of the user's hands. And they came up with the solution that you see in the sketches on the left side and on the bottom, which is basically connecting strings via hairbands to the person that is wearing the projector, the head-up display, connecting it to their hands. And those strings were connected over chopsticks and pencils to a presentation clicker. So when the person were using their right hand, they could jump forward in the slide or on the website. With the left hand, they could jump backwards. So they could interact with their head-up display. Building this, getting all the resources together, they did not have chopsticks around and probably no fishing line. That took them another day. So basically within 1 day and 45 minutes, they've designed a workable interactive head-up display that they could test with a real human being. That's pretty impressive. But as said, Google, they did have established workshops, prototyping workshops back then already. It does not have to be that advanced for everything that we started, for all ideas. What we see here is a typical toolbox for a design studio workshop. Legos are often involved, a lot of plastic and paper, cutlery, sponges, different colors of papers, glue, sticky notes, and tape. With a set like this, probably costs you 50, 60, 70 bucks. You can design quite a lot of prototypes for real physical design ideas that you do have. And I've just recently talked to a friend, and she said she used the forced isolation through Corona to actually clean out her home And because she wasn't allowed to go out and she found all that stuff that she does not need anymore, she basically just decided to build a prototype for one of her ideas out of the trash that she found in her house. So that did not cost her anything at all. And the things that you want to build are things that you can interact with. Either you as a designer, your team, or even better, in the next stage, your designated user, the person that you designed it for. And you want to get feedback if is it what you thought it would be. Like with the backpack, is the size about the one that is comfortable to wear? So it's you want to make it as small as possible to be comfortable to wear, but you want to make it as big as possible from the volume to fit stuff in it. And that's something you can figure out with such a paper prototype of a backpack. Or on the top we see toaster radio combinations where you actually can use the levers, the buttons on the front one, and you can even put a slice of toast into it. So you can touch it and you can play around with the functions. That's what you want with I would say the second stage low fidelity prototypes. Or when we go to an interactive mobile app prototype, you want to be able to slide the screens through the phone, through the mock-up of your phone. Slide the screens, have pop-ups. So when you interact with it, you hit one section of your start screen, and then manually you slide to the screen that would come up in real life. And especially when you test it with real users, you want to learn if that what came up is what they expected. You do not want to surprise users in any way. Of course, a positive surprise is better than a negative one, but with any products that we use in our daily life, we actually want it to be what the user expected it to be in the long run. Those are things that you want to learn. Positive surprises are good, negative surprises are bad. If it is what they expected, that's fabulous. Prototyping is important. Prototyping is for us to learn about the quality of our ideas. And here's a quote from Sir James Dyson, the Cyclone vacuum cleaner inventor. And he said, I made 5,127 prototypes of my vacuum before I got it right. There were 5,126 failures, but I learned from each one. That's how I came up with a solution. So I don't mind failure. If we don't fail, we will not learn. When things go wrong and we understand why things went wrong, that is when we learn the most. That's knowledge that we can carry on to improve. I would always be very suspicious if nothing goes wrong with any of my prototypes. I used to be a mechanical design engineer, and 95% of the stuff that worked out in my head did not survive the stage when I actually modeled it in 3D on the computer. And of that stuff that worked out in 3D on the computer, probably another 80% did not work out in real life when we finally build it. The sooner you can find out what is not working, the sooner you will find out what is working. And that's what I want to invite you with this event, with this session as well. We had a challenge at the end of all the previous sessions. We started with empathy mapping. We had then a session, a task or a homework for you guys where you could create a persona of your designated user or customer. Last time we did crazy 8s to ideate, and this time I want to invite you to build or draw, sketch low fidelity prototypes of 3 ideas that you came up with to solve any problem that you're working on right now. Bring it to paper, get it out of your head. If you already do have your sketches, move on to the next step and build an interactive prototype that you can test, preferably with your target customer. And yeah, interact with them and write down what you learned from your prototypes and from interacting with your prototypes. Sketch the simplest method, physical prototypes. Use the extra time that you have right now, since we do not have to commute, and see if you can build a prototype with the stuff that is sitting around at your place at home. And we're here at Think, the Think Club and Think Innovation. We do not just talk about the stuff, we actually do what we're telling people or what we're praying. So at the moment, Think Club is officially now 5 weeks old. We're just about to design a new website for the Think Club and our overarching business, Think Innovation. And my dear friend and fabulous team member Dimple is creating prototypes of the website, interactive user interface, and we would love to invite all of you to participate as testers for this website. Dimple created a form where you can register with your email address. Then she will reach out to you within the next couple of days and arrange a 15-minute Zoom session to do a live test of the UI UX of our new website with you. So if you're keen to learn how to test from the side of the user, you're most welcome to help us to optimize the user interface of the new website. I will post the link in the chat in the next couple of minutes, so you can find it easily. Just click it and fill it in, and we would be amazing if many of you would join us to help us make this Think Club the best that it can be. Many thanks in advance. And here I will finish this session today with a quote from Tom and David Kelly. David Kelly, the godfather of modern design thinking. If a picture is worth 1,000 words, a prototype is worth 1,000 meetings. And those meetings can be within your team, those meetings can be with customers. Whenever you can show something physical, whenever you can have your client or your managers interact with your idea, you will learn much more about what they like and what they dislike about it. So get prototypes out there, get your ideas out of your head, and those that survive your own testing, use those prototypes and test them with your. Awesome.